The Gaia mission is over. New Glenn gets to orbit, but loses the booster. SpaceX catches SuperHeavy, but loses Starship. And we finally get an explanation for little red dots. All this and more in this week's Space Bites. Well, it finally happened. My favorite mission is over. Now, I'm talking, of course, about ESA's Gaia mission. This is this incredible spacecraft that's been operating for over a decade, examining the stars in the Milky Way. It made 3 trillion observations, cataloging 2 billion stars in the Milky Way. This is the mission that gave us the most accurate map of the Milky Way galaxy, which is tricky to do because we are trapped inside of it. And yet, on January 15th, ESA sent the signal to end its science operations. Gaia is over. Now, Gaia isn't actually over, it's just the science operations are over. But what's going to happen now is they're going to continue downloading all of the data off of Gaia. They're going to spend the next couple of weeks putting it through some final tests, and then they're going to move it to a parking orbit. And then in March 2025, they are going to finally shut off the spacecraft. But when you look back at the 3,827 days of observations made by Gaia, we have learned so much about the Milky Way and really the universe. Gaia was able to map the positions and directions of all of these stars in the Milky Way, which gave us this really accurate view of what the galaxy looks like. And we can see that the Milky Way has this warp in it that came from a recent collision, and we learned this thanks to Gaia. And thanks to Gaia, we were able to see the movements of collections of stars that were once dwarf galaxies that had been consumed by the Milky Way. It tracked thousands of white dwarfs and other interesting objects in our vicinity. It found exoplanets just because it could. And really, the data from Gaia is still only halfway there. We've only received the first 3 data releases from Gaia. The next one's coming out in 2026. That'll be data release 4. And then by the end of the decade, we will get data release 5. And so we'll finally have the full, complete collection of all of this information in the Milky Way. Like I said, information on 2 billion stars, tens of thousands of exoplanets, as well as asteroids inside the solar system, white dwarfs, other interesting stars in our vicinity. Gaia gave us our best view about our home here in the Milky Way. Well, I'm sad to see it go, but I can't wait to see what happens next as scientists get their hands on all of the data. Starship, IFT-7. This week, we saw the 7th test flight of the SpaceX Starship SuperHeavy combo. And once again, the objective here was to test out the launch of the SuperHeavy Starship stack, test out how well the 2 spacecraft would be able to separate, see if SuperHeavy would be able to successfully return to the launch platform and be captured by Mechazilla's chopsticks, and then watch as Starship flew to orbit. Now, the Starship was an upgraded new version of Starship, and so they were testing out new technologies. And the launch went great. We saw the whole stack take off, and once again, the cinematography was top notch as we watched the thing launching. We even got audio from the launch as like some panel was flapping against the side of the spacecraft. And then the 2 spacecraft separated and SuperHeavy returned to Earth. Now, last time with IFT-6, SpaceX decided to call off the landing capture, and instead they had the booster soft land in the ocean nearby. This time they gave the command and SuperHeavy returned to the launch site, lined itself up, and then landed in another kind of picture perfect landing of this giant skyscraper booster rocket. And then Starship continued on to orbit. Now, things went fine for the first couple of minutes while we were watching and seeing what had happened with SuperHeavy, but then we could see that some of the engines started to go off on Starship, and then the telemetry seemed to just freeze. And then just a few minutes later, we got a message from the people at SpaceX that they had lost Starship. So we didn't get a chance to see the rest of its flight. It was going to be testing out deploying satellites, as well as, testing out new technologies that it would use to return through the Earth's atmosphere and soft land in the ocean. So we didn't get a chance to see that part of the mission, but we did get a chance to see that amazing capture of SuperHeavy again. So I guess we'll wait for test flight number 8. And just a few hours earlier, we saw the first launch of the New Glenn rocket from Blue Origin. And there's been a bit of a rivalry between SpaceX and Blue Origin, with both of them trying to figure out who could get their super heavy lift rocket going first. And obviously we've been seeing lots of tests from Starship, but finally we got to see a full test of New Glenn. And this is a very big rocket. It is just a little smaller than a Saturn V, and it's been under development for more than a decade. And yet, we saw this rocket take off. Now, it initially started pretty slowly, taking off from the launch pad, but then picked up speed. And then a few minutes into its flight, the two halves separated, and with the upper stage heading off towards orbit and with the lower stage coming back. Now, they gave the name not only to the drone ship, which is called Jacqueline, but they called the first stage booster, so you're telling me there's a chance, which I think is pretty funny because there was no chance. Within a couple of minutes, we learned from Blue Origin that they lost the booster, and so it didn't make it all the way down to the drone ship to be able to be caught and brought back. But the upper stage continued on to orbit and was able to maintain some time in orbit, and they were able to test out a payload called the Blue Ring Pathfinder. So it's kind of backwards from Starship. So Starship lost the upper stage, but recovered the lower stage, and Blue Origin lost the lower stage, but I guess the upper stage was successful, although they didn't recover it. So the race continues. Who knows who is going to win this one? The pressure is on for Blue Origin to demonstrate that they can launch New Glenn. They've got an upcoming mission with NASA called Escapade, and it's going to Mars. It's got to fit within the Mars window. So really, they've got to get off the launch pad again before March to be able to get the spacecraft on the way to Mars before the window closes. So we're going to probably see another launch of New Glenn relatively soon. And then earlier in the week, we saw another successful launch of a SpaceX Falcon 9 rocket, and this was carrying 2 lunar landers. Now, I talked about this a couple of weeks ago, that these were going to be launching, and now they have launched. And so the one payload is the Blue Ghost 1, and this comes from Firefly Aerospace. And this is part of NASA's Commercial Lunar Payloads program. And this is where NASA is paying to have a bunch of its instruments deployed to the surface of the moon. And so the Blue Ghost 1 is carrying 10 NASA payloads down to the surface of the moon. It'll attempt its landing and it'll remain operational for 1 lunar day. So 14 days on the surface of the moon, test out all of these NASA instruments. The second lander on board is from a Japanese private company called iSpace, and their lunar lander is called Hakuto R2. And the first Hakuto R attempted a landing a couple of years ago and failed. And so this is their chance to redo the launch, the landing, and hopefully they will successfully make it down to the surface of the moon. And you know, when you think about the number of spacecraft that have attempted a landing on the surface of the moon in the recent memory, it's not been a high success rate. So hopefully 2 more landers on their way to the moon will break the losing streak, and we will see successful landings on the moon from here on out. Flares from our supermassive black hole. The center of the Milky Way is a busy place, and this is in part to the supermassive black hole that's at the heart of the Milky Way. Millions of times the mass of the sun, it dominates this area. You've got stars going around in orbit, like planets or comets going around the sun. You have clouds of gas that are whirled together. And in fact, there are star-forming regions that are very near the supermassive black hole, which was a pretty big surprise to astronomers. And astronomers have been tracking the environment right around this supermassive black hole for decades now, across all of the wavelengths, from radio waves through far infrared, through visible light, through X-rays. They're able to see as material falls into the black hole, joins the accretion disk, and you get this flash of radiation. But one wavelength that had been missing for the longest time was mid-infrared. And this is partly just because the region around the supermassive black hole is obscured, and it's really hard to get a good telescope to be able to see into that region. And also, in general, the kinds of flashes of radiation aren't as bright in mid-infrared. But what's a telescope that we know that does mid-infrared? James Webb. And so recently, astronomers used James Webb to watch the environment around the supermassive black hole and watch as it started to produce flares in the mid-infrared. And this is really useful because now astronomers can see these flares happening across every single part of the electromagnetic spectrum. And that allows them to understand the environment around the black hole, try to take their models of how the black hole should operate, and then compare them against those observations, learn more about the closest supermassive black hole that we have. Every week, we do a vote on our channel where you tell us what you thought was the best story of the week. And the winner last week was the updated news on NASA's plans for its Mars sample return mission. So thank you everybody who voted on the channel. Now we post a new vote into the community tab within about 24 hours of when we post this episode of Space Bites. And so if you go to the community tab, you'll see the new vote, or if you're just scrolling on YouTube, you should see our vote show up. And when you do see it, then vote, and then the algorithm will continue to feed this to you week after week after week. But the best chance to see it, subscribe to the channel, click the notifications bell, and then entertain the algorithm. An explanation for little red dots. Another interesting story from the James Webb Space Telescope this week, and this is gonna probably end up being what I think is one of the most important stories of the year. Oh, now I just ruined the vote. Forget I just said that. Just like be objective about what you saw. Right, so when James Webb was starting to observe the early universe, it was doing some big surveys of regions really far away, and they were starting to find these weird, mysterious little objects. They were dull red and relatively small, and astronomers called them little red dots. And then they started to figure out how far away these things are and realize that in fact, they're not little and red at all. They are gigantic. They are heavily redshifted because we were seeing them at a time when the universe was less than 1.5 billion years old. In some cases, we're seeing them just less than 500 million years after the Big Bang itself. And so astronomers wanted to know what these little red dots were. And so there were a couple of main theories. One idea is that this is the combined starlight coming from these gigantic galaxies early on in the universe. And this started to clash with our existing theories about cosmology, that how could you get galaxies that were so big, so mature, so early on? And I think you probably heard a lot of the news that astronomers were starting to sort of have some concerns about how you could have this highly evolved giant galaxies early on in the universe. So more research was required. And so astronomers put together a survey of 341 of these little red dots and did very detailed observations of what they are. And what they noticed was that gas is swirling around the center of these little red dots at 1,000 kilometers per second. And that is not the kind of motion speed that you get of a large galaxy. That is what you get in the environment around a supermassive black hole. And so now they've got an explanation for what these little red dots are. And that is that these are the very bright centers of newly forming supermassive black holes at the heart of newly forming galaxies. And what you probably have is at the very heart, the black hole gets started and you get this region of star formation as the black hole is whipping up the area around it. And then over time, this ring of star forming region starts to move outward through the galaxy. And then as that happens, the center of the galaxy becomes less bright and in some cases becomes obscured in other gas and dust. And so I think it's great to just remember to be patient, to wait and watch, and don't get too excited about one theory or another theory. Give astronomers time to observe things, to do a more detailed, thorough investigation, and come to a more careful conclusion about what it is that they're seeing. And still, this is just early days. We still have more than a decade of observations that astronomers are going to be making about these and other objects in the early universe. But it really kind of evokes your imagination as you imagine these giant clouds of gas and dust, these supermassive black holes starting to get going, whirling up at the center as they're pulling in gas and dust, causing all this turbulence in their environment. You're getting stars starting to form in this region around that. And then as that star forming material is used up, the ring moves outward into the galaxy until you get a proper, full, more evolved galaxy. Did the quasi-moon come from the moon? A few months ago, the Earth was joined by a new quasi-moon called 2024 PT5, and it hung out in our vicinity for a couple of months, and then it sped back off into its own orbit around the sun. And this happens fairly frequently. We've known of about 10 quasi-moons within the last few decades, and so every now and then, new quasi-moon shows up, hangs out with us for a couple of months, and then takes off again. Now, PT5 was only 10 meters across, and when it reached its closest point to Earth, a lot of the world's biggest telescopes turned and observed it as best they could. And they were able to see the reflected light coming off of the asteroid and get a sense of what it's made of and what its surface is like. And what they found is that it has a rocky, silicate-rich composition. And this then rules out one possible theory, is that it might have been like an old booster rocket that was captured in solar orbit. But the chemical composition of the surface was actually very similar to the surface of the moon. And so the astronomers think that, in fact, this tiny quasi-moon might actually have been a chunk of the moon, and that some asteroid impact hit the moon sometime in the past, knocked off a chunk, and then it's been in our region of space ever since. I guess it was like it was visiting home for the holidays or something. Watching a changing universe. Now, most of the things that happen in the universe are happening at scales we can barely comprehend. They are huge, millions of light years across. They are unfolding over the eons at glacial pace, and we wouldn't be able to notice any change across a single human lifetime. But there are places where things are unfolding at a smaller scale more rapidly. And one example is this really cool place called WR 140. And if this looks familiar, it's because we talked about this story a couple of years ago. What you've got is two Wolf-Rayet stars. These are very young stars that are orbiting around each other. And it takes about just shy of 8 years for the smaller star to pass through a cloud of gas and dust that's been blown out into space by both of the stars. And as the star passes through, it's creating this spiral. And then the strong winds from these young stars are pushing this material outward into space at about 2,600 kilometers per second. And so what you get is this spiral that is moving outward. And James Webb took pictures of this area about 2 years ago, and then it took pictures just recently, and you can actually compare the two images and watch as this spiral is continuing to go out. Now, what's scientifically important about this is that these winds are blowing. They're filled with carbon dust that is coming off of the stars as they're newly forming. And this material is flying out into the universe and will enrich surrounding nebula material. This will be the raw material for other stars and other star systems. And this might be the kind of process that led to the formation of life on Earth. This is how we got our carbon. NASA's 2025 NIAC Awards. Just a quick note, we've got the new release of NASA's NIAC Awards for 2025. These are the Advanced Innovative Concepts. These are really cool ideas that NASA just wants to throw a few $100,000 at in total, but a way to explore ideas that are over the technology curve. And we report on all of them. We try to interview everybody behind all of these interviews. And in fact, I'm starting to line up interviews over the next couple of weeks, and we'll try to bring as many of these to you. And you should definitely take a look at all of the ideas, but some of them are really cool, like assembling large structures in space, using glass blowing techniques to create lunar habitats, and an inflatable star shield that could be used to image exoplanets. So stay tuned. There should be a lot of interviews coming to the channel very soon. Now, while you're watching this week's Space Bites, I am writing my weekly email newsletter. This goes out to 70,000 of my closest friends and contains dozens of stories that you're not going to see here on Space Bites. For example, astronauts just deployed the first wooden satellite into orbit. LIGO fails to find continuous gravitational waves from pulsars, and an even ghostlier neutrino may rule the universe. So if you want to get those additional stories, go to universetoday.com/newsletter to sign up. The newsletter comes out every Friday. I write every word. There's no ads. It's completely free. So check out the Guide to Space newsletter. Now, I'm going to let you know about another chance to get your questions answered, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Andrew Gross, Barry Lake Roofing, David Giltonet, David Matz, Dennis Alberti, Justin Cable, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Paul Rohrbach, Sean Sargent, Spiderswap.io, Stephen Fowler Munley, and Vlad Shiplin, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So we are at the middle of the month, and on the 15th of the month, I send out the call for the patron-only question show where all of the patrons can write in their questions, and then my producer, Anton, and I will go through all of those questions and answer them. And then we share the link with all of the patrons. So if you've got some burning space questions and you've been on the fence about whether or not to become a patron, now is a good time. We'll leave the call for questions open for a couple more days. So go to patreon.com/universe today, sign up, and then you can ask your question. And we pretty much get through all of the questions every month. So definitely check that out. And the patron question show will last 2 to 3 hours, and we've got a lot of time. It's a little more laid back. I'm able to do a bunch of research because we're not doing the show live. And so I think you will probably enjoy listening to that. And then we release the audio onto the patron only podcast feed, which you can also sign up and get all of the back episodes that we've ever done. So definitely check that out. All right. We will see you next week.